All right, today we're going to be looking at how to fill out these tables. And so we're going to go ahead and start off and jump straight in. We have our equation at the top. That's going to be really helpful for us. We're going to use that to solve the different parts. So for this first one, we've got momentum equals, so mass multiplied by velocity. Now in this case, we know what the mass is from the problem. So instead of writing the word mass here, I'm just going to put what mass is. And since mass is 2 kilograms, I'm just going to put 2 times my velocity. Now, in order to fill out the rest of this table, I need to know what velocity is. And I can see what it is on the table. So for the first situation, it's 1. So 2 times 1 is just 2. But we can leave it as 2 times 1 if we want, especially if we don't know how to multiply those two things together. Better just to leave it. When velocity is 2, we would have 2 times 2, which is 4. For the next one, 2 times 3. Oh, and I wrote a 3 times 3, so 2 times 3, there we go, is 6. And you can see that the mass is staying the same, except when I mess up. Mass is staying the same. It's always 2. What's changing is the velocities. And the velocities are matching up what we have for velocity. So this one will be 2 times 4, which is 8. Now, if we're trying to figure out which pattern this is in order to draw it, we're looking at when this x value doubles, right? When the input doubles, what happens to the output? Well, it also doubled. What about when I went from 2 to 4? That's doubling. Oh, the output doubled as well, went from 4 to 8. So when the input doubles and the output doubles, that tells you that it's going to be a proportional relationship. We can see it up on the front of the board, and that's that blue diagonal line, just like that. You don't need to do any points. You just show which of the patterns it relates to. Similarly, for our next one, this time, again, momentum equals mass, but we don't know what the mass is. This time we know what the velocity is. So I'm going to leave mass here. And again, I'm just going to put an M for mass. And then velocity is 5. So this time our 5 is going to stay the same, but our M, our mass, is going to be changing. So this time we have 1 times 5. And next one we have 2 times 5. And then 4 times 5. You got to pay attention to these because sometimes the inputs are not the same as they were on a different table. Oh, 8 this time. 8 times 5. Again, notice that the thing that's changing is the mass, because the mass is changing in our table. Our velocity is staying the same the whole time. It's always 5 for this problem. And then, of course, 1 times 5 is 5, and 2 times 5 is 10, and 4 times 5 is 20, and 8 times 5 is 40. Again, I'm trying to figure out, okay, what possible pattern could this be? Well, if I double the input, what happens to the output? It doubles. I double the input, the output doubles. Double the input, the output doubles. This one, every single input, right, is a double of the last. So that's kind of nice. But we have the same relationship that we had before. As the input doubles, the output also doubles. So again, we've got that proportional line, which I've drawn in. All right, next part. This time we have velocity equals, and we're thinking, okay, what is going on? We've got momentum equals mass times velocity. Well, I knew how to solve it when momentum was what I was trying to find, but this time I want velocity by itself. But it's being multiplied by this pesky mass. So what I want to do is I want to divide both sides by the mass. And so my equation will look like velocity equals momentum divided by mass. Okay, now I just need to know what the momentum is, what the mass is, and I can find the velocity. Well, again, for us, it tells us that the momentum is 10. So I can put 10 into my equation. So 10 divided by the mass. And I'm going to write out mass here. You don't need to. The reason I wrote it out here is because the top was momentum. They both have an M, so I don't want to confuse people in terms of which is which. 10 was the momentum. I put it on top. Mass, we don't know. I mean, we do from the table. All right, now we just got to plug some things in. So 10 divided by 1, and 10 divided by 2, and 10 divided by 5, and 10 divided by 10. And you can leave these as fractions. We try to usually give you fractions that are easy-ish to simplify, but that's not always the case. You're more than welcome to leave it as a fraction. If you know how to simplify it, go ahead and simplify it. 10 over 2 is 5, that's 2, and that's 1. Again, we can think to ourselves, what's happening as we double the input? Double the input. Ooh, this is different. This time the output got cut in half. Let's check that again. Doubling the input, going from 5 to 10 is doubling, and the output got cut in half. So if we double the input, the output gets cut in half. Well, that's that inversely proportional, the green graph. Again, I'm never great at drawing it, but you just do the best that you can, and it'll look just fine. All right, that is how we go ahead and solve these types of problems. Again, let me know if you guys have any questions or if you get stuck on any of it. Thank you.